Chris is a Chief Security Officer at Direct Defense, and he's well known in the cybersecurity community. He's part of the Cyber Patriot team. So without further ado, Chris, welcome to the stage.
Thank you. Good afternoon, everybody. This is always a fun time, try to present right after lunch. So if the room gets a little warm, you get head nods, let me know. I can walk around the room and try to jump scare people into waking up. Luckily, I do this a lot, so you're not going to offend me. If you nod off, it's all good. Shane in the back there has probably heard me do this 3 or 4 times already, so let's see. So we're going to talk a little bit about OT visibility, and I'm going to dig into a few different topics. I'll try to keep it as light as I can. This is not a light topic. There's a few other people that are speaking here today that are touching on different pieces of this, but I'm going to try to make it focused on how do you get the information you want and need, and the challenges you can face and some strategies for overcoming those. So first, who am I? And why do you care what I have to say? So I've been in the industry about 25 years. I started on the energy commodities trading help desk for Constellation Energy, which is the parent company of Baltimore Gas and Electric. I was there before they were merged into Exelon, of course, since they've been rolled back out. But we had about 1 million residential customers, electricity, about 800,000 in natural gas. And at the time, because of deregulation in Maryland, they had formed a holding company for the parent. So you had Constellation Energy at the top, you had Baltimore Gas and Electric, which was the pipes and wires delivering the electric and gas to you. We had a separate organization that owned the power generation. And so help desk, network engineering and architecture, a little bit of time supporting executives, and then I moved over and into the OT side. And when I left, I was director of IT and OT risk and compliance for all 37 power plants, including 3 nuclear. And spent some time working with the CIP version 1 program. So for anybody who's in the energy sector, NERC CIP is the government regulation for bulk energy. And all of your energy companies that deliver electricity to your home at some level have to be involved in it. Some don't fall under the CIP, which are the cybersecurity regulations, if they're really small. But everybody's got to do some of the reliability stuff and some of the other pieces. So I've been involved in that for a very long time. I'm on 5 or 6 NERC CIP committees still to this day. If you're in the drinking and wastewater space, I work with the American Water Works Association. If you're familiar with their J100 standard and you look up me or my company or a couple of my colleagues, our names are in there. And there's a few other organizations that I get involved with that I'll talk about later. But almost 10 years with them, 3 years at SunGard, running threat and vulnerability management. So we were handling vulnerability management for 1 million assets, about 250 breach cases a year, some of them full forensics, and then insourced CISO as a service for a bunch of clients. Spent 7 years with Black & Veatch, big old engineering firm based out of Kansas City, about 13,000 people. They built more megawatts of power generation than anybody else in the world, and I helped to run their security risk and compliance practice. And then for the final 3 years there, I was deputy CISO internally as well. And I've been with Direct Defense for about 7.5 years. So I have a couple of soapboxes. You'll hear a little bit here and there. Third-party vendor risk is one of them. I spoke about that at RSA last year. IT-OT convergence and how we bring people together and how those teams work together is another one that tends to be a challenge. And then network segmentation and how we get the visibility out of the OT side is another one. So we'll dig into all of those. Come on, there we go. Learning objectives, what you should expect to take from here. Understanding some basics of how you design systems to get the data flows that you need. How do you have the ability to get the information out? We need that data. Whether you're a utility, whether you're manufacturing, you have to understand what's going on the operational side. And the traditional model of air gapping has really kind of gone away. There's a lot of organizations that say they are, but most of them I find are not, even if they say they do it. Strategies for segmentation. You're not just going to be able to pick up and change this network on the fly. As a lot of you know, these systems are designed for 15, 20, 25-year operational life. They're not the kind of thing you're going to be changing components out of every 3 to 5 years, typically. So in order to make changes for segmentation, you've got to have a pretty solid strategy on how to do that. How do we overcome resource constraints? So I have never come across anybody that has enough OT staff, right? And so there's a few things you can do, give you some strategies for that, how to expand the capabilities of your team, how to use the resources you have, and where and how to pick and choose the partners. Speed of integration equates to speed of operational security. This is specifically around some of the visibility platforms. So Dragos, Clarity, Nozomi, I'm not going to pick on any one by name. If I do, I'll probably default to Dragos only because Ben Miller at Dragos is a friend and former colleague. And so I have his personal permission to pick on him and them. But it's not out of, I try to be agnostic in this space because frankly, what you have in your OT environment really should dictate the tools you're using, in my opinion. So we try to be good about that. And then talk a little bit more about staff training and incident response. So if you have capabilities for real-time operations monitoring in your IT side, what can you do to help bring them up to speed and get them a better understanding of OT? Help them understand how you need to integrate. If you've got a good solid incident response plan on the IT side, you can't just take that and put it over OT. You have to have some conversations first. You do need some custom documentation. They're going to make life easier, and they're really going to give you the ability to function properly if you do have that need. So we're going to start with the visibility problem. The visibility problem, well, first off, show of hands, who here actually is on the operations side, owns and runs some sort of OT infrastructure? Okay. How many are vendors? All right, good. So on the OT side, as a lot of you that have operational experience know, the devices there don't speak the same protocols. They're not going to run the same web browser over port 80 or port 443 that you have when you pull up a browser and go search Google. Hopefully your OT, your SCADA system is not sitting on the internet. I've had more than one client tell me that they're air-gapped, and I walked into one water utility in California, and the SCADA manager swore up and down that everything was air-gapped. And we walked into the operations center, and literally the operator who was on duty was doing his Christmas shopping on Amazon on the SCADA master screen. So, right. But the OT components, right, the basic components of a SCADA, let's step back and touch on that. Just for anybody who's not familiar, I use the example of a Nest thermostat. The three main components of a SCADA system, you've got the human-machine interface, the HMI, the piece you interact with. You've got the programmable logic controller, the PLC, the thing that does the stuff, as I like to say it. And so that's, anytime you have a digital interface to a device that's causing a physical action. And then you've got the RTUs, or the sensors, the ones giving data back. So I'll take the Nest thermostat, the touch screen on the face of it, and the app on your phone, or the HMI. The PLC is the component within the thermostat that can interface and change fan speeds and switch from heating to cooling, adjust pressures and things like that. And then the sensors are going to be the pieces that are like the actual thermostatic sensor itself, humidity, there might be a vibration sensor in the fan motor, different pieces that are giving feedback, right? Those are the components. They usually are not speaking those same protocols. So we'll see a lot of DNP, we'll see a lot of Modbus, you may see ICCP traffic. And then if you have specific industries, you'll get unusual other stuff. BACnet, for example, is one that's used in a lot of building controls. You don't see it a lot of other places. So depending on what you have, you need visibility that you're not going to be able to get with normal IT tools. If you just take your IT log management, your SIM platform, you put it in there, it's not going to understand what those protocols are doing. It's not going to understand the communications. And without that, you don't get a baseline. And the baseline of what's normal is really important because the baseline lets you know when something's different, when something's wrong. You don't have a baseline, you don't see the anomalies. So the tools you pick have to be able to understand those protocols. They have to be able to understand what's your baseline, and then you go from there. And the reason that visibility is a problem is because a lot of organizations don't want to spend the money on the OT tools. And then the ones that do don't know which one to pick. And then you do a sampling or proof of concept. You pick the platform you want, you put it in, and now you're not seeing all the data you want, and you don't know why. Most of the time, the reason is because the sensor gets put in right behind the firewall. Hopefully you have a firewall segmenting OT. I have a couple clients who are still figuring that problem out. But that traffic, for the most part, the communications between the sensors and the HMI and all that stuff, unless there's a web interface, most of the time it's going to go east-west across that network, and it doesn't come north-south to where you might put a sensor. Now, the Dragos and the Tenable OTs and the CyberXs, which is now Microsoft IoT, right? What they would really love is for you to buy more sensors. You don't want to buy more sensors. That stuff's expensive. You can also do it by buying physical taps. Then you've got the Ixias of the world and the Gigamons of the world and who else? Finisar, right? Those companies would love for you to buy their equipment, but you have to deploy lots of them. There's an easier way to do it, and we're going to dig into that. So the next one is the operations problem. For the operational staff that are responsible for running these systems, your job is to keep them running, right? What you care about really is resilience of that system. If it's manufacturing, you need your uptime. You have to keep making your widgets. You may get a maintenance outage, work with a large manufacturer that's got 37 manufacturing plants globally, 14 in North America. We've been through 9 of them, helping them sort this stuff out. The big thing for them is they get one maintenance weekend, and they get, because they run 24 hours a day, they get a total of about 12 hours once a month. So that means my planning has to be so meticulous that I can do everything I need to or be prepared to roll it back out within that 12-hour window, and if I miss it, I have to wait till next month. The operations staff also are really going to be focused on don't make changes, don't touch my stuff, and the don't touch my stuff piece extends to IT. Usually they don't trust IT. They don't trust IT because IT doesn't understand OT. They don't understand that these are different protocols. They don't understand that I can't just run, why can't I run my Nessus scanner? I'll tell you why you can't run your Nessus scanner. Because one of my friends and former colleagues at Constellation Energy downloaded Nessus on a Friday afternoon, and he had never used it. And I had just moved over into OT and come out of the network team, and I was yelling and screaming and jumping up and down saying I needed money for firewalls because the plant's networks were flat. They didn't have their own firewalls. He kicked that scanner off on a Friday afternoon on a hot summer day in Baltimore. He took 16 peaker plants offline. And why? Because the control systems for those plants were all the same. They hadn't been hardened. And the reason they hadn't been hardened is because, and I'm going to call them out for it, Emerson Ovation. Emerson at the time said, you can't do anything to our control system software. You can't change it. There's still a few that are like that, but most of them have come around. You can't patch the base operating system underneath. You can't apply security patches. You have to leave it the way it is. You can't turn anything off, right? So why, please tell me why I need a print driver running on the SCADA system running my power plant. You can't turn it off. So the scanner goes through, and it's going to hit each IP address, and it wants to scan 65,000 TCP IP ports. Each time it tried to open a port to scan it, the SCADA server said, oh, it's a print job. I'm going to give it a little bit of memory, and a little bit of memory, and a little bit of memory until there's no more memory and the system crashes. Yeah. So when the CEO pulled everybody together, and I mean everybody, 800-person IT team in cybersecurity, pulled everybody together and said, what happened? Why shouldn't I just fire you all and start over and outsource all of IT? I was like, you denied my budget for the firewalls? And he's like, how quickly can that happen? So you have to understand there's a reason OT doesn't trust IT. This is long history. This was 2003, 2004. But IT has really cool tools, and they get budget for things you don't. And so it's in your best interest to get to know them and the tools. It's in their best interest for the folks on the IT side to understand a little bit more about OT. Yeah, I'm loud enough, but I got you. And so just to make sure that everybody understands what you have. And when there are problems, you want to know those people. You want to have had a conversation. You want to have had a lunch or a beer so that you can work together better. It's not just we don't trust each other. Now we get to the cybersecurity problem. The cybersecurity problem is even the IT people don't trust the cybersecurity people, right? They sit in the corner with their hoodie on, with the lights off, and we hack away at stuff. They do an investigation, and they need information from IT, but they won't tell them what it's about. Hey, I need these logs. Hey, I need a copy of this person's mailbox, but I can't tell you anything. The cybersecurity people, for the most part, really are trying to help, and their focus usually is on risk. So they're going to look at it and say, what is the risk that this operations, whatever it is, generating power, clean water, making widgets, is going to stop? And they have to focus on what do we need to do to try to prevent that. They have a really tough job because from the outside, the bad guys are interested. They want to steal your data. They want the ransomware in place. They want to shut down your operations. They want to steal your intellectual property. And the cyber people have to go the route of, I don't want to be in a scenario where they're successful, but I also can't be the office of no. I can't be the one to say you can't do this. Because the OT people, they're back to, they care about resilience, they care about uptime, they care about the operational functions. So that cybersecurity problem is how do we effectively work with the IT staff and the OT staff and get everybody on the same page. I don't want to lead by fear. I don't want you afraid of what I'm trying to do, but I do want you to understand that there are some things that we really need to do. And it's little things like, no, everybody can't log into the SCADA system with the same admin1 username and password. Yes, you have to log out and log in at shift change, and that might mean you need 2 consoles so you don't lose any fidelity of data. So you log one in, log the other one out, log the next one in, log the other one out. Little operational changes that might not make sense at first, but it means that if something goes wrong, I need to be able to look in the logs and say, admin1 made the change that tripped the power plant. No, I need to know that it was the person that was on shift. I need to know who it was. The next one is the vendor problem. Now, there's a lot of vendors here. Frankly, I guess some of you could consider me a vendor. I try not to be the vendor problem, but the vendor challenge is you need a specific piece of equipment. You need Rockwell PLCs, you need Allen Bradley HMIs, touch panels, whatever you might need in the manufacturing space. I had a company that needed a very specific piece of packaging equipment. They made food, and so the food would come out, it would be cooked in their plant, it comes out, it gets packaged. There was one company out of Germany that made this packaging machine. And when we went to do a penetration test on it, it had a website, right? The PLC had a website. You can go and look at configurations. Well, they had never used it, and so we just opened a browser and opened the website. As soon as we opened the website, the whole PLC, the computer, the whole system crashed. A little odd, because that's part of a normal function. It shouldn't do that, obviously. Now, this was a plant that was built in 2016. We're assessing in 2017. Like, why did this happen? They had to pull the little button coin battery, off, the CMOS battery, off the motherboard of the PLC to get it to reboot. It wouldn't even power cycle when they pulled the power. What could cause that problem? Well, it was running Windows Vista, which was end of life in, let's say, 2009, for a system that was sold new in 2016. That's a procurement problem, right? That's a vendor problem. And it's not something you should have to deal with. This is a normal function for this machine. There's no way that should have happened. So there are some things you need to look at when you deal with your vendors, and your procurement people really can be a force multiplier. Everybody's afraid of them because they want to make you jump through hoops. Well, I'm going to tell you how to make them work for you. We'll dig into that a little bit. The IT/OT problem I touched on a little bit. When I first started in the power generation side of Constellation, I'd been on the network team. I had run some of the network upgrades, done some of the major stuff, some of the bigger projects. And so when the director got promoted, they asked the plant managers, who do you want to be your IT interface? And they almost all of them said me. And so that's how I ended up with the job. But when I went into that space, I had been squarely in IT. I knew a little bit. I tried to understand some things. But I said to my boss, I don't know quite how to do this job, so I would like 30 days. I want a job shadow. And so I spent the next 30 days following the SCADA techs, the INC techs and managers into the bowels of substations and power plants, looked, sat with them in their projects. Hathaway had a 1-week SCADA boot camp. I went to that. I went to the first SANS SCADA security conference in 2006 in Orlando and came to an understanding of what it was. And in that time, I saw, because I'd come from the network team, that all the OT people didn't trust the network team. Now, these are people that are implementing and putting in switches and routers and firewalls at sites that don't know anything about that world, but they don't want IT touching their stuff. So I said, okay, we have a problem here. And I went to the head of OT and I said, let's start a job shadowing program. Let's take everybody on both teams, and 2 or 3 days a quarter, somebody from network is going to follow somebody around in the substations and power plants. And then I want to take the people from OT, and I want them either with somebody from network engineering working on the projects, or I want them sitting in the NOC. So when the call comes in that the network is slow, well, it's not the network that's slow, it's you haven't rebooted your PC in 47 days, right? That they started to see and understand each other's pain. And they got a chance to have lunch together, and they got a chance to have that beer together. And that program was later adopted by Exelon, and Exelon and Constellation both still use it. That, in my opinion, is the best way to solve the IT-OT problem, is come to understand each other's day job. So what do we solve first? There's a lot of stuff up here. Well, let's start with deployment of tools. So for deployment of tools into the OT space, you look across what you have, and one of your big challenges is going to be, where do we put the sensors? Well, you can put the sensor traditionally where the vendors are going to tell you to put it, just behind the firewall. But then you need to understand where your assets are and what they're doing, those data flows. And from there, you have to understand what your devices on your network can do and they can't do to help you. So one of the biggest things that we see across all sectors is you will have a lot of unmanaged switches or dumb switches in your environment. Hey, we need a switch here next to the PLC. We're going to buy it from Hirschman. We're going to buy it from Rockwell, which is rebranded Cisco. But there are certain models that don't support RSPAN. And RSPAN is just taking a copy of the traffic that's going across the switch and sending it wherever you want to send it, to the sensor. If your switches support it, you don't need to worry about the other pieces of, hey, I have to buy these taps and put them in, or how do I route the traffic so it passes through the sensor? If it changes networks, it has to go through the firewall and then go through, you don't have to mess with that. If your switches support that protocol, you can just take a copy of the traffic and send it over there. Now, you may have switches in place that have been there for 10 years that support the protocol, but they're old enough that as soon as you do it, the processor, the memory on the switch can't handle it, and it's going to crash. You'll find that out soon enough, but it's much better if you take a look at the stats on that switch and say, you know what, this is an old Cisco IU1000, let's look at the new 3000s. It's a couple $1,000s. But in your planning process, you have to think about those things. And still to this day, in my opinion, is the easiest way to solve that particular problem. What this does, and if there's not, I don't have anybody from Dragos Clarity in the room, whatever, but one of their challenges is they go to sell you their platform, and you have 10 sites, you need 10 sensors. So you buy 10 sensors. But the speed of deployment is so slow that it takes you massive network changes for you to get the data you need for it to work right, that after 3 months, you're still not fully deployed. And so over the course of a year, you get 2 or 3 sites fully deployed. And now at the end of that year, you go back to them and say, well, I bought 10 sites, but we only got 3 deployed this year. So I want you to give me the money back for the other 7, and then we're going to buy as we go. And they're like, no, wait, right? And you may have even bought deployment services from them, but their deployment services are just going to be, hey, we're going to put the sensor in behind the firewall. We'll tune it so you get what you need for the dashboards. They're not going to get down in the weeds and say, you need to take these 50 assets and make a new network over here. You need to replace these 8 switches. You need to change the firewall rules. You need to route the traffic this way. Those are the pieces that are going to speed your deployment, that are going to let you get the actual data you need much more quickly. The next piece of that is data flow. So as I said before, most organizations, you want data out. You can't just leave it behind the firewall like you used to. I need to be able to see, if I'm making widgets, how many widgets am I making, which batch process order is it, what raw materials do I need to reorder. If you're in manufacturing, you probably have an MES, which is just the interface between the SCADA system, usually the historian data, and sending it over into whatever the sales side system is, whether it's Salesforce or SAP or Oracle, whatever you've got for your operational side on the sales and marketing piece. Being able to look at the data flows and understand where that information is moving and then know how the company is using it is really important. A lot of times if I go to a client and I ask for a data flow diagram, they don't have one. They'll hand me one that just has the switches, and it might have a little box that says, you know, this is manufacturing line 1, or this is the name of this substation, or this is in the power plant, right? This is the generator, this is the HRSG, this is the cooling tower, in the water space, right? These are the purifiers, this is chemicals of this type, this is the lift and pump stations, wastewater, here's the digesters, whatever it is. So when you look at all of that, understanding where that information is going and how the company is using it is one of the most important parts of this project. And that's where, if you don't have that, you can do it a couple of ways, but usually you have to capture some traffic and understand what's talking to what to be able to figure out why you're doing things the way you are. Visibility, I'm not going to dig into a lot here because I spent some more time talking about it, but primarily what you want to be able to do is to see that traffic and understand a lot of the visibility tools are going to show you asset A is talking to asset B on this protocol. Asset C is talking to asset D on this protocol. That starts to give you the big picture, and it'll give you a nice, pretty map, typically. Now, how do you find the assets that you can't see? And you may know they're there, right? But you might have a PLC that's functioning as a data concentrator where one device has an IP address and everything behind it is physically connected. This is still largely a world where you've got 4 to 20 hardwired devices, or you've got Modbus or DNP or another protocol that's running over serial. It's not IP-based. Those directly connected devices, they're hiding behind that IP address from your visibility perspective. So the vendor that you pick, the platform that you choose, has to be able to interrogate that device and say, tell me what's behind you. Tell me the data that's coming out. And most of the modern devices that can do that, but there are challenges sometimes when they can't. And there's some other ways around that. But understanding those assets and understanding how you get to see them is one of the more important challenges that you're going to face. A lot of times, I'll be given a spreadsheet, or I'll be given, hey, we've got this asset inventory tool. IT has some cool stuff, but the IT asset inventory relies on active scanning, active discovery, which is a huge no-no in the OT space. Nobody wants active scanners in this space. There are some effective ways to do it, but we'll touch on that. The active discovery side, in order to get what you need, should be as close to passive as it can be. You shouldn't be running like ping sweeps and things like that. Lots and lots of things get really unhappy when you ping across a network in the OT space. You can use things like SNMP. SNMP is used by NOCs and SOCs around the world to interrogate a device and say, hey, how you doing? Are you okay? How's your processor? How's your memory? How's your uptime? How's the family, right? We want to be able to get that data out, and SNMP is an effective, safe way to do it if your devices support it. So when you talk to procurement and you give them a list of things you need for the next project, make sure that the vendor you pick supports SNMP. Make sure they support syslog so you can get the log data out. The other piece about active discovery is these are things that you don't need special tools to do. So there are some free tools. You can use Wireshark to take data captures. You can use some of the other tools that would be utilized for ping and things like that. Nmap is a dirty word in this space. Nessus is a dirty word in this space. Nmap is built in under the hood of a lot of the other scanners for the discovery piece. So if you have Nessus, or if you have Rapid7's Inside VM scanner, for instance, and you do the discovery scan, you can run it from the command line. It's using Nmap. And Nmap has a bunch of things you can turn on and off. So what's important? By default, it's going to hit a whole bunch of devices in series and then wait for them all to respond. You need to slow it way down. So the time between device needs to be tweaked. Give those devices 2 or 3 full seconds. Forget milliseconds. Give them 2 or 3 full seconds to respond. Then make sure that you're hitting commonly used ports. Don't scan 65,000 ports. Most of these devices have a web interface on either 80 or 443. If you know you've got a common one that's using another port, throw it in there. 8443, 8000, 8888. Look at the documentation. Take the time to understand what you're interrogating and build your capability out of a free tool. The next piece in looking at that is once you get the data out, you can then go a step deeper and connect to that device and say, what are you, who are you, and when you build your asset management side, label it. Label the device. This is the PLC that's for this plant. Don't just leave it in a default, because what will happen is you'll have an emergency and you'll go to look at the auto-generated map in this expensive tool you spent all this money on, and chances are it's going to give you the IP address maybe, or the MAC address, the hardware physical address. That doesn't help you. Half the devices are using network card chipsets from Broadcom. They're all going to say Broadcom. Not useful. So take the time when you build that inventory and understand the network and do the active discovery to actually quantify what they are. And then you can look at it and say, how do I want to break this down? Maybe all of manufacturing line 1 should all be grouped together. Or maybe all of the digesters and wastewater should be grouped together. Or maybe it's by site. Have a logical conversation with the business, get business unit buy-in on why you're doing things the way you are, and have that understanding for how things are going to go. When you choose your vendors, you need to make sure that they have a cybersecurity program. It's not just you. Nobody can ever tell me the name of the HVAC company that caused the Target data breach. Target was breached because they had data centers and they had a company that had a service contract for the chillers to keep the data centers cool, and that company had remote access to monitor the chillers. And it was a small mom and pop shop, under 50 employees. They were really good, they were boutique, they were regional, but they don't have the money for extensive cybersecurity controls. So the bad guys, instead of trying to breach this huge corporation, said, let's find somebody who can help us. They breached that organization, they got into the chillers, they got from there into the data center, they got from the data center over about 6 months. They were low and slow, they took a lot of time. And they got into the point of sale system where they stole everybody's credit card information, and that's how you and I all got 3 years of free credit monitoring. The only nice thing about that is that about the time that credit monitoring expired, Experian got breached, and then we all got it again. So, you know, at this rate, we'll just all have free credit monitoring forever. Make sure you take advantage of that, by the way. But your vendor choices should be made on understanding that the partners that you pick should have capabilities to defend you the way you want to defend yourselves. And in this world, there are a lot of integrators, right? Sometimes the integrators are engineering firms. Sometimes they're like electricians. They're the ones that are going to run the wires. They're going to put the devices in. They've got the contracts with inductive automation, with GE, iFix, with whoever. They're going to install those control systems in the PLCs and help you build, and some of them are very customized. But make sure that they don't need to be a cybersecurity vendor. They don't need to have those capabilities, but they do need an internal program that they're doing basic things. Are they patching their own stuff? Are they running a basic antivirus? Do they have a vulnerability management program? Are they disabling accounts when an employee leaves? That's one of the big problems, right? Smaller companies, they don't necessarily disable accounts. They fire somebody for cause. You know, they get drunk and didn't come to work one night, and the next day they're able to log in remotely, and they already know who you are as the client. They know how to cause all kinds of problems. So make sure that they have that program in place, and you should be having some basic procurement language too. So we'll touch on that. Secure remote access. I can't tell you how many times I've gone into an environment. Could be energy, could be water, could be wastewater, could be manufacturing. You've got that specialized piece of packaging equipment that I told you about before. You bought a maintenance contract when you bought it, and the maintenance contract comes with free remote monitoring. So they put it in their contract, hey, we're going to install TeamViewer, and we'll use that to tunnel out, and we'll have remote access. No. This is your environment. You're the system owner. Be the owner. Control what's allowed in and out. Develop your own secure remote access. And for the love of all things holy, don't leave it enabled when you don't need to. Turn it off when it's not actively being used. If it's real-time monitoring and they need data, proxy the data. Don't just let them have direct access from outside to inside, from the internet, inside to see the data. Put that data on a syslog server, put it in some other proxy, and give them access to it 5 milliseconds, even 1 minute delayed. It's not going to hurt their functionality, and it will save you, I can tell you. Building controls and physical security is another huge thing in this space. A lot of organizations don't have the knowledge around those pieces, and so they outsource them. I spoke at ISC West 2 weeks ago about physical, cyber, converged, IT/OT. Our penetration testers' favorite way, and the first thing we do, is we go to Showdown and we look for unsecured cameras and NVRs. It's our #1 way in. Because those vendors care about getting it up and running and making sure the data is flowing, making sure you see your data, their analytics are working. They're not worried about turning off Telnet or making sure that you've got role-based access control to the cameras. That's not what they're focused on. Make sure your vendors are doing that stuff, or have somebody internally who checks it, or use a partner that can do it for you. You've got 3 easy choices there, pick one of them, but make sure you're thinking about those ancillary pieces. Data use, for the most part, I've already covered, making sure you understand how your data is being used so it comes in and out with the right flow. Resource constraints, as I said before, nobody has enough staff. Nobody has enough people in the OT space. You can cross-train the IT staff. This goes with the job shadowing. They're going to have a lot of the basic functionality knowledge that you want to need. Take the time to educate the ones that are interested. Maybe offer little perks. Get them, a jacket or a hat or something that's from the operational side of the organization. Maybe they get a little pay bump if they become proficient in certain parts of the OT systems. There may be other people in the organization that are doing jobs that are functional in manufacturing, or maybe they're system operators and you want to cross-train them for the industrial controls piece. And then if you don't have those options, find a partner. Find a partner who is knowledgeable and can help you in this space and give you the extra hands, because invariably you'll have some big project and you'll have the pieces you want that you need to keep in-house, but you've got other mundane stuff like rewriting your firewall rules and figuring out where those unmanaged switches are. Or get an intern. That's another good way. There's interns out of a lot of the colleges have cybersecurity programs now. Look for the NSA Centers of Excellence in cybersecurity. Take summer interns and give them some of those projects. Carve them out. Figure out what you need in that space. The last piece here is the staff training, and this is more around security operations. So if you've got a NOC or a SOC and they're currently watching the IT stuff, get them some training on the OT stuff. If they don't know where to go, there's a gentleman who speaks at some of these conferences that's an acquaintance, Mike Holcomb, Holcomb. He has 25 hours on YouTube of free training. Basically, OT 101 from start to finish, OT cybersecurity. Great resources. Idaho National Labs has a 3-part free course. It can be taken remotely or in person, totally free. It's INL, it's like 101, 201, 301. Those resources can help train your staff. Or you can come to firms like mine, and we will custom build the training based on what you need and come and help train the staff, or find a partner that can monitor for you. So the MSSPs in the IT space, some of them get into the OT side and have that functional capability. I touched on procurement being your friend already. Give them the requirements. Get the contract language. You specify remote access. You specify that if there's a vulnerability in a product that you purchase from them, that they're required to tell you when they become aware of the vulnerability. Don't wait 6 months until they have a fix, because you can put something in place to protect yourself if they tell you about it while they figure out the fix. Little things in procurement language can make a big difference. Now, we talked a little bit about vendors. How many times have you been looking at products and you've engaged a few vendors and they take you out and they buy you lunch, and they take you out for happy hour and they buy you drinks, and you get a little too close to them and you don't do all your due diligence because now they're friend, now you're buddy. And a couple weeks later, you turn around, you wake up, and you've contracted a vendor-transmitted disease. Nobody wants a VTD. Do your due diligence on your vendors. Have the conversations. Make sure they've got a cybersecurity program in place. Look for ISO 27001 certification. Look for a recent NIST cybersecurity framework assessment by a third party. Look for a penetration test in the last year. Look for a tabletop exercise in the past year. Make sure that they're doing the basic things that should be done to make sure that they're not the source of your problem. The other thing you can do, you have new systems in place, maybe even you don't have new systems in place, they've been in place for a while, but you haven't engaged in this cybersecurity journey, is get tested. The best way to avoid the VTDs is to get tested. Get a pen test. Find somebody who knows the OT side who can do it safely and securely, and will give you options, right? When we go start that conversation, I've got 3 or 4 or 5 options, and it's based on the age of your equipment, how resilient it is, whether or not you've done it before, the kinds of things that you want and need to know and understand to make sure that it's not going to be a problem. That's it.